So Mark, where's everybody? What's going on? I sent another message out. Well, 6:07 or whenever you're ready. Actually, if you're the only one here, I'll wait for you. Let me know when you're ready to go over anything, and heck, I'll just go over it. I'll send one more message out though. Page 81, is that one of the older lessons, I guess? I mean, I'll go back, it's no big deal. 81. Let's say what, number 40, 42. Okay. All right. Get rid of that. Okay, so 42, find the central angle of a sector. Okay, if the circle containing it has a radius of 6 feet, and the area of the sector is 12 pi. So we're talking about area. So when you're talking about area, make sure you remember the formula. Now this one, I think I wrote the answer. Actually, I can bring it back. Okay, I wrote the answer either in degrees or radians. It just depends. I didn't really specify. Just because it's harder, I guess, because you don't do it as much. Let's just do the radian. Really the same process except for the formula. Yeah, it was. I'm sorry. You're right. Because I don't know if you can see it. I have my little note up here, and I put the line down, and I only read the bottom half. So we're good. I was confusing that for an older assignment, but we're fine. So like I said, anyway, with 42, I'm just going to do the radian one, and the only difference is the formula that you would use to solve this. But the formula is going to be, area of a sector. So I'll do area of a piece of pi equals x over 2 pi, 60, times pi r squared. Now, if you at this point, what you're going to do is you're just going to plug in what they gave you into that formula and see what you get. This one, the radius is 6, so I'm going to plug in the radius. They're looking for the angle, so that'll go away. It won't go away, that's what we'll solve for. But 6 squared, as I'm plugging in for r, is 36. So that's 36 pi. And they said the area of the sector is 12 pi. The area. So the two things that I've plugged in for are my area and I put for my radius. So those are the two things right now. And at this point, you're just going to do some math. You're going to solve this out. So one thing you can do, maybe simplify stuff. The pi's are going to cancel. I also can go 36 divided by 2, which is 18. So that'll make this a little nicer looking. I'll have 12 pi equals 18x. That's just 36 divided by 2. I'm just simplifying those two values. And then I'm just going to divide by 18. And that cancels out. Remember, x is our angle. So if I simplify 12/18, that's if they both go into 6, that'd be 2/3. So that's 2 pi over 3. And that would be your radian answer. Again, the only difference, I'm not going to say twice, but if I did it in terms of degrees, it would just be x over 360. And after you simplify everything out, you get 120. But it's again the same process, just different formula to start with. But that was number 42 on page 81. And again, I'll just keep going to the next, and if you have any questions, let me know. But that was the one that you had. If you have any other ones, let me know. you're the only one, I might even put you up as a. Do you have video, Mark? We could just do a two-way chat because basically what I'll be doing is I'm recording this anyway. So anyone who's not, maybe they're on vacation or whatnot, and that's fine. They can just watch the video of it that I'll post online.
Can you hear me?
Yep, I hear you.
Yep, I hear you.
I'm a little delayed, but whatever. I can bring the audio. That's annoying. So when I talk, about 3 seconds or 4 seconds later, my audio, I can hear the audio. Are you able to turn the volume down to a point where you can still hear me?
Here, say something.
Testing.
I can hear you now. Good.
Okay. I mean, if I hear like the echo effect, it makes it kind of hard. I'll try to turn mine down too, and that way I can at least hear you. And if it still picks up, then maybe I have to turn the audio off. I'm gonna try it since it's just us two. Okay. So, were there any other questions that you had from the homework?
Not really. I got all of it. Understood it.
Okay. All right. That's good. Trying to just go over. Let me get that off. Okay. So just to kind of go over where we're at right now, I can probably, and I'll bring the schedule up. I want to make sure I got it right here. I always like to start off with just kind of going over the schedule, so sometimes it's just for me to remind myself of what I need to do, but it also kind of helps you guys know what we're going to be doing today. You can't see right now. I'm just bringing up the web page that I have the schedule on. Okay. I can kind of bring it over. No, I can't. Never mind. Doesn't work. Okay, so we have basically today and next week. I really want to finish everything. I will kind of say this now. The final exam that we're going to be doing, the way I'm going to work it out, the first hour of class on July 26th, we'll be taking the exam. We have that little thing that I can do on the Click Webinar page that way I can bring up a quiz. I'm gonna bring up like a real one, so I'll make it up, and we'll work on that for the first hour. We'll kind of review that during the second hour, so I can kind of get those results and kind of see, I can just get immediate feedback from you guys and see what kind of questions you still had, and maybe even give you some study tips from that point. But that's what we're going to do in that last day. So the goal for now is really I have 2 days to finish Algebra 2. We barely started it 2 weeks ago. So again, we didn't get very far. It's one of the tougher lessons, I would say. So it gives me some time not to rush through it. And we'll still have time that last week again to do that exam, and also still have time to review that. So that's where we're going. So we are on. I did not write that, did I? I don't think I did. Did I? Shouldn't be there. You remember? Yeah, okay, never mind. I got that far. Okay, that's where I left off. Okay, cool. Never mind. We did get that far. I take 2 weeks off and I forget everything. Okay, I'm probably going to, just so you know, I'm probably going to take the audio off just because the feedback it's driving me nuts. I hear myself talk every 2 seconds. So I just do the old-fashioned way. You just type out something if you have a question. Cool. I'm not going to be able to talk or pay attention. I'll take that off Q&A mode. You can probably hear me now, right? Okay. I put it in the wrong mode. I put it into presenter only mode. You're not a presenter, so my bad. Okay, so what I was saying is, we barely started quadratic functions last time. So at this point, what I want to do is I want to do that brief overview of quadratics. Obviously, we've already worked some of these out. So I still have number 2 I can do as like a refresher for the example. But I do want to talk about the concepts because, we're only hitting one concept in these first few examples, and then I got to go over some other stuff, which will kind of go back to this introduction. So that's where I'm going to start here. So starting with quadratic functions, there are 2 types of equations you need to be able to work with on the SAT. So you have your standard form and you have your vertex form. So your standard form, again, is that ax squared plus bx plus c. Again, I'm sure you've seen that before. But again, the key components on this, as I kind of break it down, first component is the a and what it tells you. Now, a is the leading coefficient, or the coefficient in front of the x squared term. If that coefficient is positive, it's a U-shaped parabola, and that's what you'll see in my little picture here. U-shaped parabola, a is positive, and if a is negative, it is a N-shaped yeah, sorry about that. I don't know why it decides to only crash on me while I'm doing this class. Maybe because I have a lot of videos and stuff up. Let me get my desktop loaded back up, and I'll kind of get back to where I was. Let's see. Desktop. Okay. All right, so it should be good. Now, what I was talking about before I got shut down, I was talking, the leading coefficient. Again, what that's going to do to your parabola. If you're in vertex form, again, it's the same thing. Again, if A is positive, you got a U-shaped parabola. If A is negative, it's an N-shaped parabola. So what that'll typically do, if you're trying to find a graph of a quadratic function, typically that's going to knock out half your answers. There's only 4 answers anyway. Usually half of them are going to be U-shaped and half will be N-shaped. If you have that information, just knowing that one thing will at least eliminate half, which is good when you don't maybe get stuck on the other half and you had to guess. It's a 50-50 instead of 1 out of 4. Much better opportunity on that. So that's true for both. That doesn't really change anything, whether it's standard or vertex form. Still, though, I'm dealing with standard form. Now, again, with standard form, the other part here is going to be C. C is just your constant, just like when you're dealing with the slope-intercept form equation. Again, if you're dealing with slope-intercept form, you got your y equals mx plus b. B is your constant. It's your y-intercept. Over here, C is your constant. It's your y-intercept. It means the same thing. It just happens to be called C here because it's your third constant. So they just kind of go in order A, B, C, I guess. So that's just your y-intercept. So those are pretty simple things that if you're trying to find a graph, sometimes that's all you need to know. You don't need to worry about the vertex. Usually you do, but sometimes you might be able to get away just by knowing those 2 things. The vertex, however, is, again, with standard form, kind of remind you guys last time I was talking about how you find the axis of symmetry on a parabola. Well, the axis of symmetry, if you're looking at this line right here, it goes through the vertex. So if you know how to find the axis of symmetry, you can use that information to find the vertex. So again, the axis of symmetry was x equals negative b over 2a if you have a standard form equation. So what you'll see, the vertex, the x value of the vertex is negative b over 2a, which is the same equation you use to find the axis of symmetry. Now, if you know that the vertex is at that point, let's say for instance, like we're looking at this problem, it's at 1, then the y value would be f of 1. You would just plug in that x value, and you get your y value, just about by doing just simple evaluation. So that's what this second part comes in. Again, I just use 1 as an example. But the formula, again, is negative b over 2a. You get a number. That represents a number. Then we're going to go f of that number to get the y value of the vertex. And that's how you'll find the vertex of a quadratic function in standard form. And then again, those other two components are very simple components to apply. You don't really have to do any work to find if it's a U-shaped or N-shaped parabola. You don't have to do any work to find the y-intercept. You just need to know those concepts. The one you have to do work on is that vertex. Otherwise, it's pretty simple. And then you get your vertex form, which again, it's there to find the vertex. I mean, that's why it's there. So the vertex form, again, for this one, the vertex in this case is at h comma k. So I kind of use an example up above here. Like to say this was an equation in vertex form. Notice the x plus 3, that tells you your x value of your vertex is at negative 3. It's always going to be opposite if it's inside the parentheses. But the y value of the vertex is negative 5. That's not in the parentheses, so it's not going to be opposite. And again, those things you just need to kind of learn in terms of formulas. You make sure you understand which one's positive, which one's negative, which one's not. But if it's in the parentheses, it's the sign switch, the signs switch. So that's your vertex form. Again, you don't have to do much work to find the vertex there. K, notice K is not the y-intercept in this case. So don't use that as the y value of the vertex, but it's not the y-intercept. So again, it's just understanding these properties will definitely help you find the graphs or draw the graphs if you have to. Now, one thing we did last time, just as a reminder from some of the stuff that we had already done with completing the square, sometimes they will kind of ask you to find the equation of a quadratic function. And in order to do that, you're going to have to take the equation and put it into vertex form. So that's what we are doing on 1 and 3. I'm going to use number 2 just an example since it's been a couple of weeks since we've done it. So number 2, just to kind of run this down, and then we'll move on to the new stuff. If you want to put this into vertex form, we have to complete the square because it's x minus h quantity squared. So I need to get a perfect square in my equation. So it's just a quick reminder of what we're going to do on these. So first thing I would do is get that constant out of there. I'm going to start from scratch. I'll call this f of x y. So I'll have y minus 1 equals x squared minus 6x plus blank. And I'll even move this down a little bit so it doesn't get confusing there. So if you remember what we did on this one, again, this value right here, I'm just doing it so there's an example. This was b over 2 quantity squared. So in this case, that would be 6 over 2. 6 over 2 is 3. 3 squared is 9. So I'm going to add 9 here. And anything you do to one side of the equation, you must do to the other side of the equation. So adding 9 over there as well. So now I have y plus 8 equals, and now this better be a perfect square. In this case, that is a perfect square. It's x minus 3 squared. And then I subtract 8 from both sides, and you get your vertex form. All right. I hope this doesn't happen again. I mean, I'm going to keep trying at it. If it becomes like a big issue, like the worst case scenario, I'll have to like record the class and upload it. I hope that doesn't happen because I'm recording it now. But yeah, I don't know why it's doing that. It hasn't done that in like almost 2 months. But anyway, I'll keep going and hopefully I don't have any more issues. But like I said, it does it randomly. I don't get it. So anyway, did you get the end of this problem? Are we good? Okay. So I'll try to get to new stuff here. I'm going to go as quickly as I can. I'm getting behind already, obviously. So anyway, the next part here is we're going to start solving. You'll see we'll be finding roots and things. We're going to start solving quadratics. Now, if you're trying to solve a quadratic, one thing they're going to do is they're going to ask you for a solution. But sometimes what they'll do is, yeah, I still see your chat, Mark. Like I said, it's not even my computer. I mean, it is actually. It's my computer. I bought everything brand new on my computer except I used my dad's old video card, which was a super expensive video card. And he just bought a super duper expensive video card. So I even updated the cooling system on the computer. So it's a really nice computer. I'm assuming it's a video card. It gives me video exception error when it shuts down. So I don't need a video card. They're just so expensive. It's scary to buy one. And I was gonna get one, but then it like stopped messing, or stopped doing this until like now, and it wants to do it 5 times in a row. If it shuts down this time, this is the last time. If it does it again, I'm gonna try to just do a video on my own, because I don't know if it has to do with all the stuff I have up. I don't know. I'll try it one more time. Like I said, if it shuts down again, like I said, you can log off. I'll upload the video as soon as I can get this dang thing to work, and we'll do that. I apologize for that. It's annoying. But this time I'm hoping this time. The last 2 times it shut down, I sent you the text message. I'll just let you know. The last 2 times it shut down, I just hit reset as soon as the screen popped up, but then I read it and it's like it was doing like a scan. So I let it scan and then restart on its own. I'm hoping that might do it. I hope. If that doesn't do it, then I don't know what to do. Except buy a new video card. I might just go on Amazon today and buy one and get a 1-day delivery on it if I can't get anything to work. So I think I'm going to need to do that anyway. Anyway, let's try this one more time. Like I said, if that doesn't work, then you can log off. I'm not going to waste your time anymore. So let's see what happens. Let's share my desktop one more time. What's weird is I've been doing this class has only shut down that one time, and it's been fine. I don't know why it's doing it 4 times in a row, or 3 times, or whatever. Here we go. Okay. Cross my fingers. Okay, so anyway, what I was trying to talk about, I'm kind of scared to start talking because last time I started talking it shut off, but I'll try it. So we were talking about solutions quadratic. So one thing, when they're asking you to find the solution to a quadratic, they won't just say find the solution to this quadratic. I mean, they can, but they like to kind of use different types of words. So I'm throwing some of those words out there so you understand. A solution to a quadratic, like if you had a graph and a quadratic function, the solutions are going to be these points right here if you were given the equation. That's what the solution is. And the solution is an x-intercept. If you kind of see that's your x-axis, that's where an intercept's the x-axis. But they have different names as well. Obviously, x-intercept is a solution. So they say find the solution, they're saying find the x-intercept. They say find the x-intercept, it's the same as them saying find the solution. Those words are interchangeable. Another word that you may see is the word roots. Again, a root is an x-intercept. A root is a 0. A root is a solution. So all those words are completely the same. I put factors in there, even though a factor technically isn't a solution, but if the solution is x equals 1, the factor is x minus 1. So it's kind of related to the solution. So all the work would be the same. You just leave it in its factored form. So I kind of put that in there under the solutions because it says find the factors. You're going to approach it the exact same way. You just write your answer as a factor. That'd be the only difference. So again, understand what those words mean. They all mean in terms of the way you approach it. The other thing about factoring, you're going to have to know how to factor. However, there are some factoring rules. Please know those. You got your first one I have listed there is your difference of squares, and then you have your 2 perfect square factors. Especially that first one, the difference of squares. You just want to know that by heart. That shouldn't, be anything you're scared of. As soon as you see 2 terms, like here's an easy one, x squared minus 81. You should immediately know that's x plus 9, x minus 9. there shouldn't be much thought to that. Just like that's just how you factor it. If you see 4x squared minus 36. Actually, I don't want to use that one because you can GCF that. Like 25. You should know that's 2x plus 5, 2x minus 5. It's a difference of squares. Anytime you see two terms being subtracted from each other and it's a quadratic function, you're going to use that difference of squares. We'll do a couple examples of those in just a second. And at the same time, I kind of started talking about it just briefly. You may have missed it, but the other type of factoring you always want to be looking for are GCFs. You want to be able to pull out a greatest common factor whenever possible. It's best to do that first and then see whatever rules you can, because then you're dealing with smaller numbers, so it's kind of nice to pull those out early rather than later. But basically, again, know what a solution is and the different ways to word it. Know how to factor. Know your foiling distributive property. Foiling is distributive property, so I kind of put a slash in there. And the last thing that you kind of need to know is going to be, again, your quadratic formula. So it's there. I'm sure you've seen it before. Again, I'm not teaching this as something brand new, so I'm not going to talk about it too much. But you need to know that formula. And again, what quadratic formula is, it gives you solutions to a quadratic function. Typically, you need the quadratic formula, however, when the solutions aren't exactly pretty, which means you couldn't really factor the quadratic because the numbers are going to be like 2 plus or minus the square root of 7. You want to be able to find that in a factor. So that's what the quadratic formula is used for, is when you can't factor. Okay, so basically you can put that in there. Use when you can't factor. And with that, let's go ahead and try some of these. I'm just going to kind of go through some basics and kind of work our way down, starting with number 1. Now, with any quadratic function, again, just as a reminder, your answers, it's a quadratic, so you normally are going to have 2 answers. So your solution could be something like this, where you have 2 x-intercepts, and they're going to be unique. The other situation you may have something like this, where you have one solution, but it repeats itself. That would be like a perfect square, like x minus 2 quantity squared. That would be that function. And then you can have a situation where you have no solutions. So that means it doesn't touch the x-axis. So I want to remember that, because like something like number 1, some people will just square root this, and they'll say x equals the square root of 10. And there's a problem with that. It's quadratic, so it should have 2 solutions, whether they are 2 real solutions. It could be a perfect square, or they can be imaginary, which means they'll have that I in it. But there's going to be 2, even when that happens. So you can't have one solution to a quadratic. The simple rule is this. It's a square. It's a second-degree polynomial, so it'll have 2 solutions. The power of the polynomial tells you how many solutions you're going to have. So in this case, that's where people make that mistake a lot. It should be, in this case, plus or minus the square root of 10. Just again, a lot of times people forget that plus or minus, but there's going to be 2 solutions. So when you square root, number plus or minus. That's all you have to do, number 1. Very simple, just about knowing the plus or minus is going to be in there. Number 2, we can do the same thing on this one, except it's going to add another step to the end. Here, you can square root. That one's ugly. You can square root both sides. So here I'm going to get x minus 5, still plus or minus the square root of 10. Notice this one just has an extra step. This is what's going to, your quadratic formula problems are going to look like when you're done, but it was in a different form. I can just solve it using algebra. But here I just add 5 to both sides. And you can't combine these terms because one's a square root, one is not. So x would be 5 plus or minus the square root of 10. You could put that at the end, it'd be plus or minus the square root of 10 plus 5, but that won't look as nice. And that's not what your quadratic formula solutions will look like, so this one will kind of stay consistent with that. But notice there's 2 answers, 5 plus the square root of 10 and 5 minus the square root of 10. Okay, both of them are nasty, but they're answers. So that's number 2. Number 3. Number 3, again, some people will confuse this with a difference of squares, so they'll just go x, they'll say x plus 1, x minus 1. But it's not a difference of squares because it is a sum of squares. Now, if you know this one rule, it'll save you a bunch of time. There are no real solutions to a sum of squares. There's no sum of squares factoring rule because you cannot factor a sum of squares. And when I say you can't factor and get a real answer. So what that means is you're going to have an imaginary answer. So what you would have to do is you'd have to try to solve it. In this case, I would subtract 1 from both sides. So I get x squared equals -1. And again, when you square root a negative number, you're not going to get anything. Like you can't. Let's just go ahead and do it. I'll talk about it. So if I square root that, remember this is still going to be plus or minus when you square root. So I'm going to get x equals plus or minus. And again, the whole idea of the square root of -1 is what can you multiply by itself and get -1. That's how you find the solution to square root. And there's nothing. It doesn't exist. So that's going to be what's called an imaginary number. We call that I. And I'm sure you've seen that one before if you haven't, or if you don't remember as much. I have a section dedicated to it here in just a little while. Actually, it'll be next week. That's just, again, square root of -1 is I. But we have to have the plus or minus in there. You got to have 2 answers, not just one. Okay? Again, try and go through these as quick as I can. Remember, it's just you, so if I'm going too fast, you can always tell me. And if it's easy for you, tell me. I can speed up because when people are watching on video, they can always pause. Number 4, I'm just going to GCF. Okay, so I'll go quick. Number 4, I'm just going to GCF this out. I see a 2x is a common factor in these. I'm going to go 2x. Pull that out. This is going to be x plus 2 equals 0. That's all I'm doing. So that's just an easy factor. So 2x equals 0 and x plus 2 equals 0. And again, Mark, just so you know, if it's easy, I'm going through each one because other people will be watching the video, as I'm hoping. So I want to make sure I still cover it, but I'll go quick. Okay, and if I'm going too fast, just slow me down. So in this case, if I solved each of these factors, and again, this is how you solve quadratics in general. If other than the first examples I gave you, general rule is to factor it if you can, and set each factor equal to 0. So in this case, I'm setting each factor equal to 0. So that would be x equals 0. That's a solution, or an x-intercept. And here I subtract 2, and x equals -2. So those are going to be your 2 x-intercepts on number 4. Again, you have 2 unique answers. Number 5, this one, it's saying find the solutions. This one I probably should have set it equal to 0. You notice all the others are set equal to 0. You can just equal 0. That's just a typo on my part. That's all it is. So this one is just a simple factoring one. So what you're going to do is you're going to set up into 2 binomials. And the way I factor, I do it a little differently than most people do. I say what 2 numbers multiply to give you x squared? Well, that's x and x. And then I say what numbers multiply to give me 12? There's a few. We have 4 times 3, 6 times 2. We also have 12 times 1. The first factors are going to go first in your binomials. So I know it's going to be x and x. It's the only way to get x squared. Now with the 12, there's a few different ways to get 12. But notice this number in the middle. It's a -1. So I'm going to pick the numbers here that differ by 1 because those are probably the ones that we need. So I'm going to put 4 here and 3 here. So those are going to be your constants. Now what you do if you were going to multiply this out, you would multiply your first terms, that's going to give you x squared. You're going to multiply your last terms, that's going to give you 12. The question is what signs do I need to have here and here to get a -1x in the middle? And when you FOIL, it's those, in this case what you're going to have is you're going to have a 4x and you're going to have a 3x. To get a -1x, this 4 would have to be a negative and this 3 would have to be a positive. So this is a -4 and a +3. Call it the rainbow method. It looks like a little upside down rainbow or a tire or whatever you want to call it. That's how I do my factors. It's the same thing as anyone else does. It's just a different way of writing it. But once you factor, again, rules, factor, and then set each factor equal to 0. So x minus 4 equals 0. X plus 3 equals 0. And you get x equals 4. X equals -3. Again, 2 solutions. In this case, they're 2 unique. You can sometimes have them repeat. Sometimes they're imaginary. There's times they're 2 unique solutions. Okay. Number 6, again, just moving through this. This is going to be another factoring problem. First thing I want to do, look to see if there's any GCFs. There are not. So I'm just going to go ahead and start factoring. So I look at the 3x squared. I know that is 3x times x. There's no other way of doing that. And I know 1 is 1 times 1. There's no other way of doing that. So this one is all dependent upon the signs that I use. So when you set up your two binomials, you're going to have 3x and x for your first terms, and 1 and 1 for your second terms, or your last terms. There's no other way of really doing it. We just need to worry about the sign. So if I'm looking at the sign on this one, I'm just going to go 1x for my inside term. I'm going to go 3x for my outside term. And I want to see, can I get -5? In this case, you cannot. So if you cannot do that, then that means that this one is going to be factored using the quadratic formula. So this is where it's nice to know the quadratic formula. If you don't, then you need to learn it because they don't give it to you on the test. So here's a reminder. This is A is 3, B is -5, and C is -1. We're just going to plug and shove and see what we get. So if we do that, it's x equals -b, which is 5, plus or minus the square root of b squared minus 4ac. B squared is -5 squared, so that's 25, minus 4 times a, which is 3, times c, which is -1, and that's all over 2a, which is 6. And again, I'm doing it quickly, again, assuming that you're doing okay with this, but the formula's up there. If you're watching on a video, just pause it and kind of check each term with the formula, okay? All right, so at this point, I'm just going to simplify the radical. So you can use a calculator for that to save time. It don't matter, but I actually probably don't need to. Here, one thing I do, I just kind of check my signs. I have two negatives, so I know I'm going to be adding. That just kind of helps me kind of speed through that part. So 4 times 3 is 12. So 25 plus 12 is 25, 35, 37. Oops. And that's over 6. And you can probably leave it like that because you can't simplify 37 since that's a prime number, and 5, 6 doesn't simplify either, so that's probably how you want to leave it. The only other way they could write it on the SAT is 5, 6 plus minus the square root of 37 over 6, or they just separate that common denominator. But either way, like if you have that answer, you should be able to see that. Okay. Another thing about number 6, sometimes you may already know that you have to use quadratic formula, because if you're looking at multiple choice answers and solve these, you probably wouldn't be trying to factor it. So that might save you some time on that. That's where looking at the answers kind of helps. But you ain't going to get that by factoring. Okay. Number 7, again, using that good pace. This is a difference of squares. Again, you see how there's two terms and you're subtracting. So this is going to be x plus 2, x minus 2 equals 0. Set each factor equal to 0. And you're going to get x equals -2 and x equals +2. Again, I almost want you to just do that in your head. Like if you already know that, you're like, I knew that answer in my head. Yeah, that's good. That's kind of what I want. Just showing the steps and showing how quickly, that can be solved. Just simple difference of squares. Number 8 is also difference of squares. You kind of look at it and say, well, I can't really pull out any GCFs, even though I got some numbers in there. Hopefully, it'd be nice if you could, but you can't. But these are still perfect squares. So this is going to be 3x plus 4. Notice I'm square rooting the first term and the last term. That's a plus b, and then a minus b is 3x minus 4. So even with those numbers in there, those coefficients, it's still a difference of two perfect squares. You just have the 3 and the x together, because that's 3x quantity squared is 9x squared. So I still have perfect squares, and I can still solve it the same way. 3x plus 4 equals 0. 3x minus 4 equals 0. Set each factor equal to 0. This first one would be -4/3, and the second one would be +4/3. That's your difference of squares, no big deal. Okay, so you want to know those. Super simple. Okay, next up, got another difference of squares. Again, this one you can't pull out any GCF. 36 doesn't have 5 in it, so This is the same exact problem. So it's 5x plus 6, 5x minus 6. So this would be x equals negative 6/5, and x equals positive 6/5. You can also write this, you may also see it as an answer as plus or minus 6/5. And again, understand what that represents. That represents your x-intercept. So if you're trying to look at a graph of it, you'd be looking at the graph that goes through plus or minus 6/5, or something just above 1 and just below -1. If you see that graph, you probably got your answer. And because it's a positive 25, you know it's a U-shaped graph. So a couple things you can kind of look at. And the y-intercept's at -36. Cool stuff. Okay, got 3 more here and we'll move on. So I think after this, we just have, we'll write in polynomials. Okay. Number 10, again, doing this one, I want you to kind of look here. Easy way to catch a potential perfect square factor is the first term and the last term is going to be a perfect square. If you see that in a trinomial, I want you to kind of try to see if we got a perfect square. In this case, you just try to factor it, and you should have the same numbers for both factors. So x and x gives me x squared. Let's try 3 and 3, which gives you 9. Okay. Now, again, hopefully you can kind of see this already, but this would be 3x. This would be 3x. If you made them both plus, you're going to get 6x. So this is a perfect square. Okay, that's the factored form. But the answer, you set each factor equal to 0, you're going to get x equals -3. Now again, remember I said every answer has 2 solutions if you're dealing with a quadratic. This does have 2 solutions. It's x plus 3 and x plus 3. It just happens to be repeating. They call that in algebra a multiplicity of 2. You don't need to know that for the SAT, which is why I'm not writing it here. But that's what it is. Okay, there's technically 2 answers. They just happen to be the same answer. So that's number 10, just perfect square. Again, you're looking at 11, another perfect square. Again, it doesn't, just because you have 2 perfect squares doesn't make this a perfect square factor, but it probably is, just because that'd be an awfully big coincidence if it wasn't. So you just test it out. Again, you just go x and x. Sometimes you don't need to test it out by writing it out. You can kind of do it in your head. I'm writing it out so you can see it. This one would be 5 and 5. If I want to get a -10, I'm trying to save some work here. I subtract. -5 and -5 equals -10. So this is a perfect square factor. So set that equal to 0. Again, it's the same answer twice. A lot of times you can just do all this without writing a thing down. I'm just trying to show the bare minimum to at least show you what we're doing. And then number 12, again, notice perfect square, perfect square. So let's test this out and see if it is a perfect square. So this one, this is, again, combining some of that stuff I use with difference of squares. I'd go 2x and 2x. That's 4x squared. And then 9 is 3 and 3. With this one, that would be 6x. 6x. If I made both of them minus, I would have a perfect square. So this one is also a perfect square. And the way I catch it, I see a perfect square for the first term and the last term. So I'm going to test a perfect square factor first and make sure that works. So this one, you're going to set 2x minus 3 equal to 0. X equals 3/2. Just has a multiplicity of 2, but who cares about that? We just need the answer. Okay, and that's basically solving quadratics. Again, it sounds like, Mark, you're pretty good at that, which is great, because I have a bunch of these. So if you know how to do it, you're good. And we do the SAT part of it. I don't know if you've done that part yet. It does go into some of it with the graphing as well. Just kind of focus on this part for the math camp. Just make sure you know how to solve them. Polynomials, kind of move into that. So with polynomials on page 90, some of the things that are going to be the same. First off, a polynomial is basically a quadratic actually is a polynomial. A linear function is a polynomial. But again, polynomials allow you to expand the degrees beyond degree 2, which is what a quadratic is, or degree 1, which is what a linear function is. So polynomials could be degree 1, 2, 3, 4, 5, 6. For example, it's a polynomial, like 7x to the 5th minus 4x cubed plus 2x squared minus 3. There's a polynomial for you. Not a fun one, but that's what a polynomial is. It can when you say quadratic, you're kind of bound by the degree. It has to be degree 2. It has to be a parabola. A polynomial, however, can be any degree, but it is basically a list of terms being added or subtracted from each other. And typically, when you write it out, generally it's going to go from highest degree to lowest. Sometimes they can mix it, they can mix that up, but generally that's what you're going to see. So that's what a polynomial is. So again, what you'll see is a lot of the concepts are the same. Obviously, you're going to have higher degrees, so you can't use a quadratic formula here. Sorry. But again, solutions are the same. And all a polynomial will do, a graph of a polynomial would kind of look like this, where a quadratic polynomial is just a U-shape. When you start adding degrees, you just start adding loops or humps or whatnot. So, a polynomial may look something like this. This would be, just so you're aware, because of the zeros, that's 1, 2, 3, 4, and these are two imaginary zeros here and somewhere there. Remember, you can have real zeros or imaginary zeros. Those last two, you see there's a hump there. It just didn't go down far enough to touch the x-axis, so it's considered an imaginary root. But this would be 1, 2, 3, 4, 5, 6. This would be a 6th degree polynomial, just so you're aware. Again, they don't really get into those graphs, but I'm just kind of giving you the visual of it. But anyway, as you go through that, the solutions of polynomials will be called the same things quadratics, because they basically are the same things. They can be zeros, x-intercepts, roots, factors, and so on. Factoring, again, a lot of the rules are the same. You may say, how can I deal with these same factoring rules? You'll see. Because what they may do, instead of saying x squared minus y squared, they may say x to the 4th minus 16. It's a 4th degree polynomial. It's not quadratic. But it's x to the 4th is a perfect square. That'd be x squared plus 4, x squared minus 4. So basically, like I said, you'll see some of these concepts can still apply. Same thing with perfect square factors and such. So we'll go through that. Factor by grouping will pop up here. You'll see that. Say example below. We'll talk about it. And then GCFs still apply. The other thing, this is the new stuff, you will be asked to add, subtract, or divide polynomials. The big thing that I just say, read this. I'll highlight the keywords. Maybe you can circle those. Subtracting, that's really where the only issue will pop up. These are pretty easy for the most part. Dividing, I don't know, maybe there's a little bit of work to do with that. But adding is simple. Just combine like terms. You'll see that and we'll go over it. Subtracting, the negative sometimes will cause an issue because people will not distribute the negative. I'll go over that through the examples. But if you can remember that, subtracting is easy. Dividing, again, is going to involve a little bit of long division, more so really synthetic division. The last thing, and we'll just go over it when we get to it, is the remainder theorem. I'll talk about it when I see the example. This is a very simple thing as well. Some people may not have even heard of it. Usually, for me, I was taught in pre-calculus. I'm teaching algebra 2. So if you haven't done that class, then you're probably going to have a hard time with that one. Or you won't have a hard time with it. It's very easy, but you may not know it at this point. We'll go over that. Okay, so just those are all the concepts you'll have to do. Notice some of them are the same, some are new. So let's kind of get started with it. First things first, we're going to do adding and subtracting of polynomials. I'm just going to go through one of them. I'll go through number 2. They're basically the same problem. It's just different terms and whatnot. So I want to start with number 2. Basically, all they're asking you to do, this notation just means add and subtract. So you'll see that's what I'm going to be doing. The first one I'm going to do, I'm going to go f plus g of x. That means add f of x and g of x. That's all that means. So that means I'm going to do this. 2x minus 5 plus x cubed minus x. That's an ugly. There we go. And again, one thing I always do, I'd like to put these terms in parentheses. You'll see why when I do the subtraction. But again, super easy. All you need to do on this, understand, first off, when you deal with the terms, if you can simplify either one of the functions, simplify that first. Here you cannot because there are no like terms. But if you look at each individual function, there is one like term here with the x's. So I can combine those. So when I write this out, I'm going to start with my highest degree. I'm going to work my way down. So the first term you would write is going to be your x cubed. The second term you're going to write is going to be the x. That's the next degree down. There's no x squared term here. So 2x plus negative x is 2x minus 1x. So that's going to be plus x. And then I just copied down my minus 5. As I said, these are pretty simple because all you're doing are combining like terms. There's really not much else to do. But when you subtract them, I'm going to have a slight issue here. I don't call it much of an issue. I'm going to copy and paste because it's pretty much the same problem. It's going to change this to a minus. So you'll see it's the same problem. I'm subtracting now. So that does make a slight difference. I still have the same like terms. All that stuff's the same. The one simple little issue that people have, it's easy fix, you just got to remember it, is that minus, you're subtracting the entire quantity, which means you're subtracting every term in that second function, which means, long story short, you need to remember to distribute that negative. So if I wrote this whole thing out, this would be 2x minus 5 minus x cubed plus x, because it's minus a negative x. That is the #1 error students make. Once they figure it out, it's never an issue anymore. But like usually when I teach it, it's like right away, I see that. Maybe about a quarter of the papers, and then they start slowly disappearing as I make a big deal out of it. So again, you have to distribute, which means that if you mess this up, you're just messing the sign up. You're going to subtract x instead of, in this case, actually adding it. So this would now just be a negative x cubed. 2x plus x is 3x minus 5. Pretty simple fix on that. Just got to be careful. That's all. Okay. I just want to make sure I'm still doing a good pace. I'm trying. I think I'm going kind of quick, but I'm not trying to go too quick. You just always tell me. Next up, I'm going to talk about division. Now with division, you'll see every single one of these division ones, and I just try to tie it to the SAT. They typically are just going to have you divide. Okay, that's good. They're going to have you divide linear by linear factors. In this case, you'll see x minus 4, x minus 3, x minus 1. So until I see them force the issue, I'm only going to teach you one method of polynomial division. And again, Mark, you're in the Thursday class, so if that changes, we get to a point where, because that May SAT is going to be released any day now, maybe even before Thursday, we'll see. And I see on that May SAT they have you do long division, polynomial long division. I'll teach it. I'll go over it. But until I see it, I'm not going to waste my time. So again, what we're going to do, we're going to do a method called synthetic division. And it's a process. Again, I'm not going to teach it from scratch. I'm going to show you this is how you do synthetic division, assuming you've seen it before, and this is a reminder. Okay, so here's how you do synthetic division. Now, the only time you can do synthetic division is if you're dividing by a linear factor. So if I was dividing by like x squared minus 4, I could not use synthetic division. I would be forced to do long division. But because I have yet to see that be forced on the SAT, I'm not going to teach that. I'm going to talk about it. So I'm going to do synthetic division. Here's how you do it. I'd like to remind you the root or the 0 or whatever is 4. This is the term we're going to use to divide. Yeah, and that's good. I'm just doing the reminder. And again, remember on this mark, I'm teaching this to even the people that aren't here. So again, I'll go quickly because I know you don't have to worry about pausing. You can't pause. But I'm going to do it real fast. So and synthetic division is really fast. So the first one I'll do kind of at a pace where I'll show you, and then the other ones we're going to fly. Because that's how I really want people doing synthetic division, just fly through it. What you do is you write down the root, which is 4, and then you write down the coefficients for, in this case it is a quadratic, that's going to be 6, negative 26, and 12. Just be careful in case you went from x cubed to x, it would be 6, 0, negative 26. You have to include every term whether it's there or not. And here's how you do synthetic division. You that's your setup. You write your coefficients, drop down the first term. And here we go. 4 times 6 is going to be 24. So you enter the product under the next term, and then we're going to add these two terms. Negative 26 plus 24 is negative 2. Now I'm going to multiply again. 4 times negative 2 is negative 8. Then I'm going to add one more time, and that gives me 4. Now the way this works, this last term is always going to be called your remainder, and this is your quotient. So if I wrote the answer out, notice there's only 2 terms. So this would be your constant and then your linear term. I always start with the first term, work the way up. So the first term in your quotient, or the last term written down in your quotient, is the constant, and you work up a degree each time. So this is going to be 6x minus 2 plus 4 divided by, and I'm dividing by, remember at the top, x minus 4. They will write the answer out in this form, so you need to know how to convert that. So it's always quotient plus remainder divided by divisor, I guess. That's the template you'll have. Again, you will see that template on SAT questions, so you want to make sure you recognize how to convert it. Okay, and that's synthetic division. Again, I would recommend, if you're watching the video, you pause it, kind of go back over that before I do these next ones. These next ones, I'm just going to fly through it. So I want to make sure you understand what process I did, because it's the same thing every time. I want to see how fast you can do these, because there are certain ones that you may have to do it 3-4 times in the problem to see which one matches, you know, what quotient you're looking for, and you may have to do a bunch of division. So you want to be able to do it quickly if you can. So here we go. This next one, I'm going to write down my root, which is 3, and my coefficients are going to be 2, -7. Notice there's no x term, so you have to include a 0 there. That counts. And then 5. Again, I had no x term, so I put a 0x. That is important. And here we go. Bring down the 2. 3 times 2 is 6. -7 plus 6 is -1. 3 times -1 is -3. 0 minus 3 is -3. 3 times -3 is -9. 5 plus -9 is -4. And I could do it quicker, but you know, maybe I'll do that in the last one, but super fast. But here I go. Remember, this is your remainder, and this is your quotient. Again, starting with the -3, that's your constant. Therefore, -1 is a linear term, and 2 is your quadratic term. So this is a quadratic quotient. So this would be then 2x squared minus 1x, or x, minus 3. And because that's a -4 for the remainder, it's minus 4 over my divisor, which is x minus 3. Done. Okay, let's try to speed up a little bit each time. But that's just all we're doing. If you know the process, it's very simple. The next one, I'm going to write this down quickly. So that's a 1 for your root. So it's going to be 1x squared, -5x, and 4. Okay, no terms. I didn't skip any terms this time, so I don't have any zeros. Okay, bring that down. 1 times 1 is 1. -5 plus 1 is -4. 1 times -4 is -4, and these cancels out and gives you 0. Okay, yeah. That's my, what do you call it? Auctioneer talk real quick. In this case, I have no remainder, so I don't need to worry about that quotient plus remainder concept. I just write down my quotient. And again, this one, -4 is a constant, 1 is a linear quotient. So this will be 1x, or x, minus 4. And if you kind of look at that number 3, if you tried factoring it, those would be your factors, x minus 1 and x minus 4. So I guess it makes sense. That would be your quotient if you pulled out an x minus 1. All right, last one. This one, your root is -5, so write down -5. Your coefficients for your quadratic here are going to be 4, x squared, 0x, because it's not there, and -3. And here we go. Pull down your 4. -5 times 4 is -20. 0 minus 20 is -20. -5 times -20 is 100. -3 plus 100 is 97. Okay, these should go real quick. Okay, so this one, again, this is going to be 4x minus 20 plus 97 over x plus 5. I mean, if you wanted to, I doubt it would be that way. You could pull out a 4. That'd be x minus 5 plus 97 over x plus 5. I doubt they would write that, but hey, there it is, in case you want it. So synthetic division, again, that's something hopefully you can be real good at. If you are, then this is not a difficult concept. Again, study that first example. I kind of went over the steps on that one, and I kind of hurried through the others, repeating that same process with just different numbers. And the next one is your remainder theorem. Now, before I just do this example, yes, pacing. Cool. With this, if I go back, I went too far. Sorry. There we go. Remainder theorem. Here's the remainder theorem. It's all it's saying. If you have a function and you're able to divide it by x minus c, you're going to get sometimes a remainder. That remainder is significant in more than one way. It is what's left over after division, but it's the same thing as if I took this function. So actually, I'll show this first, and I'll show you an example. So if I divide by x minus c, and I get a remainder r. So let's say I divided by x minus 2, and I got a remainder of 3. That's also telling me that if I did f of 2, I evaluated my function at f of 2, I would get 3. So it's a nice little shortcut, and you'll see what I mean. They'll give you a question that's on the no calculator section, and they'll tell you, hey, if you divide this by x minus 7, you're going to get 12 as a remainder. Find f of 7, and the number is going to be gigantic. So it'll be impossible for you to actually evaluate it. But they just gave you the answer if you know the remainder theorem. They said f of 7 must be 12, because that's your remainder. So like if I went through these problems that we just did, like number 2, and I say this was f of x. Okay, and I wanted you to find f of 3. You should just know it's negative 4. Because when we had divided, that was our remainder. Okay, that's all you know for remainder theorem. F of 3 would be negative 4. If I came down here, and I want to say this is my function, I wanted to find f of negative 5. Well, f of negative 5 is 97. Because we already did the synthetic division, we got a remainder. That's what the hell we're doing. Kind of nice. And they don't even make you do the long division, at least in the ones I've seen. I actually don't do this one very often, maybe once a test. So I don't have too many examples to go off of. But this is what it would look like. Okay. Or this is what a hard one would look like, I should say. They don't even make you do this. They usually will tell you f of x, here's f of x. If you divide it by x plus 2, you get a remainder of 7 or something. Find f of negative 2, and you write 7. Like, it's even easier. But I want to prepare you for the worst case scenario where they make you do the synthetic division. And once you do the synthetic division, you can use a remainder theorem to evaluate this function. Here's the issue. This problem will be on a no calculator section. This would suck to plug in negative 2. You got to raise it to the 5th, and then to the 4th, and then to the 3rd. You got to add all these, multiply all these. It is so much faster to just do synthetic division. And here's how you do that. This is the root, okay? That's the root. That's the term you're dividing by. So what you're going to do, instead of evaluating it at negative 2, you're going to do synthetic division with negative 2. Basically, you're dividing out an x plus 2. The remainder of this synthetic division will be the solution to f of negative 2. That's your remainder theorem. I can do a giant long proof, or you just trust me. Okay, know that theorem. It's kind of helpful. And I actually tested it, so it's kind of nice to know it. So here's what we would do. We'd write down negative 2. That's the root. We're going to be trying to divide out. This will be, your coefficients are 3, 5, negative 4. I'm skipping x squared, so you have to write that in. That'd be 0. And then 7x, and then 3. Notice all those numbers are small, and the numbers I would normally be scared of, we're not even dealing with, which is the x to the 5th, the x to the 4th, and the x to the 3rd. I don't have to worry about those. So that makes this a lot simpler. This is why I said this could very easily be on an SAT. Like, if they just want to make this problem a little harder, this is all they'd have to do. So I don't see this as an unrealistic SAT question. It just hasn't popped up yet. I've only seen four or 5 tests. So here we go. Pull down your first term. Negative 2 times 3, that's negative 6. Subtract, because that's plus a negative, that's negative 1. Multiply, that's going to be positive 2. Subtract, add negative 4 plus 2 is negative 2. Multiply, that's 4. Pull that down, that's negative 8. then -1, and then +2, which is 5. That's your answer. Your remainder is the answer to this. So f of -2 equals 5. That is by the remainder theorem. It's pretty sweet. Okay, it's easy to know. Like I said, on the ones I've seen so far, they don't expect you to know the remainder theorem, so they literally give you everything you need if you just copy the answer down. We're not going to do that on this problem. I don't want to make you work for it, but that's all. That's all you got to do. That would definitely be a super hard problem. It would be one of the last ones you would do in the math section on the SAT, because I can guarantee you either people aren't going to know how to divide, they're not going to know to divide, which means they won't know the remainder theorem. But even if they did, maybe they don't remember how to divide it. So there's two big things I know are going to stump a lot of people, either or, maybe both concepts. So that'd be nice. That'd be a hard problem. Okay, so that's going to be the polynomials. Now, at this point, what I want to do, I want to go through exponentials tonight. So yeah, I'm just going to do the exponentials tonight, and then we'll kind of wrap up with that. So that's where I'll stop. We'll see what time I finish. I'm at a point, though, if I got shut off, we'll just kind of keep this as the class, and I'll just have to maybe get a new video card for next week. I'm going to see what happens. Hopefully, we can get through this. So exponential functions, page 93, that's the last thing I'm going to do. I want to talk about, just as a setup on this one, before we get to the examples down here, I have all these concepts I want to talk about. Exponential functions actually come from sequences and series. And the concept of sequence and series, you have arithmetic sequences that you probably learned in algebra, and you have a geometric sequence that you also learn. An arithmetic sequence of numbers is basically a list. If you're doing a sequence of numbers, all they would be doing is they'd be giving you these. They wouldn't be giving you the x values. So you would look at this and say, okay, so all that's really happening here is I'm adding 3. And it's a consistent value. Okay, well, this is the same as a linear function. This would be called a slope of 3. That's all it is. I just want to make that connection. A linear function is an arithmetic sequence with inputs. That's all it is. You're adding or subtracting a constant value. It can be the same as if you're subtracting. This is -3, -3, -3. This would be the same as having a slope equal to -3. Okay, so we dealt with linear functions. Talked about that concept. Very simple. You have an equation that represents these. It's y equals mx plus b, and it has 2 parts to it. It has a slope, and it has, and I like to word it this way sometimes, an initial value. Remember that initial value is considered the y-intercept. But remember on the SAT, they like to say the word initial. So that's your linear function. And again, I set this up this way because exponential functions are really just the same rules, just shifted a little bit. Because again, if you talk about sequences, usually talk about arithmetic and geometric like back to back. Because they're very similar, they just have that one difference in how the numbers change. But beyond that, there's a lot of similarities. So like here, the only difference with a geometric sequence is that you're multiplying. Instead of adding 3, you multiply by 3 every time, which means this thing's going to explode. If you multiply by 3, it's going to grow a lot faster than something that's just adding by 3 every time. So this would be called, in this case, a rate, just a general rate. So the rate is 3. Sometimes what they'll say on the SAT is it grows by 300% per maybe year or week, whatever they're using for the input. They'll usually tell you what that part is. But they're going to say it grows by 300% per month or per week or per day or per year or whatever. If it's going down, you don't really have a negative. A negative doesn't really exist. All the negative will do in the geometric sequence is flip the whole graph. If you want something to go down, you end up multiplying by a fraction. That fraction is going to be between 0 and 1. Like if you multiply by 1/2, your number goes down. In this case, you're multiplying by 1/3 times 1/3. 2 times 1/3, 2/3. And you do that each time. Times 1/3 times 1/3. So that's how you're going to go down. So this would be a rate equals 1/3. But this one, what they would say, this is you're going to go down, and this is what you'll see. I'll talk about it here in just a second down below here. But if you're dealing with this as a percentage, you're actually going down by 33%. So that could be per week, per year, whatever. And I'll talk about how we actually calculate that, and then we'll kind of go over that. Actually, no, I said that backwards. Sorry, this is what I was getting to. If you're going down 66.6%, you'll see what I mean when I get to it. That's how they would say it on the test. I'll explain that here in just a second. But again, what I get to that, the concept I'm trying to talk about right here is you have slope-intercept form, which kind of comes from arithmetic sequences, where you have a constant slope, which is how much you're going up or down by adding or subtracting a number. And you have that initial value. Here is your exponential form. It has the same parts to it. A, which is, in this case, your y-intercept or starting point, is going to be one of your terms. B is a number. Notice B is connected to x, just in a different way. See over here, your slope or your rate is connected to x. Well, in this case, your b, your base of your exponent, is connected to x. So it represents your rate of change. Okay. The other term is that y-intercept, or that initial value. So there's a lot of similarities, except again, in this case, instead of adding a, it's not like b to the x plus a, or m to the x plus a, it's if you're multiplying. So it is a little different. But again, remember when you are doing arithmetic sequences, you're usually adding or subtracting numbers. When you're doing geometric or exponential functions, you are multiplying. So it makes sense that you'd be multiplying by a, not adding a. So again, you want to understand what a represents, what that term represents, and what b represents. So for example, I came up here, my rate was 3. You would just say y equals 3. Actually, that's not my initial value. This one doesn't have an initial value. I would show you how to do it. This one would be a times 3 to the x. That would be the equation. Now, if they wanted you to find the initial value, you would just plug in a point. For example, the point 1, 2. So I would just go 2, which is my y value. I'm just using this point. You can use any point you want, but you might as well just use the smallest numbers. 2 is my y value. That equals a times 3 to the first power. That will represent your x value, which is 1. And that's just basically 2 equals 3a. Divide by 3, and a equals 2/3. And here is your complete function. Y equals 2/3 times 3 to the x. So that would be your exponential function for that. And we'll do some other ones actually in just a second for the other graphs. So that's basically how exponentials will work. You need to understand the formula for it, understand what a represents, what b represents. They kind of test what those mean on a lot of the mediums. Medium is sometimes even a hard question, just depends how many students know this formula. Very simple if you know the formula, because again, most of the questions you're going to get are literally just testing how well you understand y equals a times b to the x. So super important you know that. Other parts just to make sure we're good at, remember b, I kind of mentioned this, if b is greater than 1, your rate is greater than 1, that means you're going up. As you multiply by a number greater than 1, you increase. If it's a fraction between 0 and 1, it's going down. That's really all you need to know on that. The other part, and I kind of put it in here, I mentioned it a second ago. Okay, so SAT questions, I'm just reading this first paragraph that relate to exponential functions or concept problems. Look for terms such as increasing, decreasing by X% per year. So remember when I was talking about rates, I'd say they'd be mentioned as a percentage. So if they're mentioning percentages, that's a huge sign that you're dealing with exponentials. That's how they typically deal with the rates, as a percentage per whatever. And you have like decay. Yeah, it means you're going down. That's even when you learn it in math, it's called exponential decay. Right? So see that word, probably deal with exponential. And obviously the word exponential. Important note here we go. That's what I was talking about. An object, I'm right here. An object, they say something, an object decays by 7% per year. Going back to a percentage unit way back when, you're doing in this case to find that rate, the actual rate that you plug in for B, you would have to subtract that number from 1, like 100% minus 17%, because that means you'd be left with, after a year, you went down 17%, you'd be left with 83% of that original value. So that's how you go down 17%. You multiply by 1 minus 0.17. So the only other things you'd have to know, again, I'll just tell you, study these. You know your exponent rules. Okay, most people are good at the top 3, and they kind of have issues at the bottom 3. I mean, I'm going to go through these examples real quick and knock these examples out. I have basically just 4 problems to do, and then the exponent rules. So let's just do these and talk about it. Again, Mark, you know you're here, so if you have specific questions on any of them, let me know. Usually the first one's typically good at, and then after that, then they have some issues. Remember, you're multiplying. I know your exponent rules. These are just the algebra rules that you probably learn in algebra. You're multiplying, you add your exponents. So this would just equal 2 to the 3 plus 5. So that's 2 to the 8th. We'll just leave it like that. That's usually how it would be left. Again, you multiply, you add your exponents. I'll color code this. Next one would be a power to the power rule. You multiply in this case. This would be 2 to the 3 times 4. When you raise a power to a power, you multiply your exponents. That's 2 to the 12. Again, I'll leave it like that. That's your power to a power rule. Next up, we are going to be dividing. When you divide, you subtract your exponents. So this would be a to the 3 minus 5. Now in this case, I'm going to get a negative exponent. I'm going to get negative 2. So I just applied right now. I applied this rule right here, but now I have a negative exponent. So I'm also going to be applying this rule right here. If you have a negative exponent, we're going to make it positive. That's going to be our simplified form. It's kind of like if you're dealing with fractions. You have like 6/10. You don't leave it as 6/10. You leave it as 3/5. You simplify the fraction. So we'll do the same thing here. So in this case, I'm going to move this to the other side of my fraction, and it'll become a positive. So it'll be 1 over now a squared. So with that, I won't keep color, because if I keep color coding all this, they're all going to be mixed up. So from these next ones, I'm just going to do the exponent rules, and we'll knock this out. First off, this next example, I see that we're dividing, and I want to subtract the exponents, but what you'll notice, you can't subtract unless the bases are the same. So in this case, I got to do a little bit of simplifying before I can apply that exponent rule. So in this one, I have 16. That's 2 to the 4th power. That's 2 to the 4th raised to the x. We want to get the bases the same before we can apply that exponent rule, which means I got to use some other exponent rules to get that to work. So this is a power to the power, so I'm going to multiply. I have 2 to the 4x divided by 2 to the y. Now I can apply my exponent rule for division. This one is going to be 2. It's not equal to 2 to the 4x minus y. And I'm done. Okay. But this one, again, a little tricky. It's simply like, oh, geez, that's all I had to do. Again, this is just trying to give you an example of something that you'll see this, but something you might see on an SAT where you have to simplify before you can apply one rule, you got to use another. That's what I'm kind of doing on some of those. Now this next one, another simple rule. I'll even color code this because we haven't used this one yet. I don't think I did purple yet. This is just going to be this rule right here. And the way I always remember these, basically you got to understand a radical is basically just a fractional exponent. But sometimes people mix up the numerator and denominator of that fraction. So here's how I kind of remember these. Imp is your power. So notice that's a to the m power. Power, if you're powerful, you're going to go on top. You're not going to go on bottom. What does go on bottom are these guys right here, which are called roots. And roots go underground. So it makes sense they would be on the bottom. And if something's powerful, you're going to put it on top. This is the nth root of a to the m power. That is an easy way to remember what term goes where. We'll circle that, because I'm color coding here. So this is just as simple as knowing that this is the third root, so that's going to be your denominator, of y to the second power. So that's y to the 2/3. Power on top, root on bottom. Done. Again, that's another one of those ones that if you know the rule, it's super easy when you take the SAT. And last one is a combination problem. What you'll see here, there's a lot of different ways to approach this. I'm going to kind of give you a heads up. There's no one right way to do it. So, but if you had to try to come up with one rule, and again, not even a rule because you can do it any way you want. I'll say, hey, simplify what's in the parentheses first. If you think, just go back to PEMDAS, parentheses and exponents, right? So I'm going to go ahead and simplify the parentheses in this case. But if you want to distribute that -2 to everything and then simplify, you could. But generally, that's not as good. It makes things a little worse. It doesn't really matter. But like I said, if you want to have one rule, that's the rule to follow. Simplify the parentheses first. So that means I'm going to subtract my exponents. I have x to the 6 minus 7 and y to the 2 minus 1. Again, that's all to the -2. You'll get that in just a second. So this is x to the -1, and 2 minus 1 is 1. I'll leave the 1 there just for now. Okay, so I just simplify that and it looks a lot nicer. It looks a lot nicer again to simplify that and then bring in the -2. Now remember, this is power to a power now. So when you bring in the -2, you're going to be multiplying each one of your exponents. So this will be x to the -1 times -2 is +2. And this will be y to the 1 times -2 is -2. So again, I just use my power to a power rule. Finally, notice I have that -2. So I'm going to take that -2 exponent, just that -2 exponent, I'm going to move it to the denominator, and it will become a positive exponent now, and that'll be my simplified form, and that'll be y squared on bottom. And that is how you do that one. It's a lot nicer once you simplify it. Okay. Again, there's so many different combinations of exponent you can use. You just want to be good at them. If you have any questions on them, again, we'll go over them next week, especially if you're not here right now. Just bring those questions with you next week. We'll go over it. You'll see next week we will have time. I'll finish early. I'll have time next week to go over the exam and questions and whatnot. So I'm trying to keep that pace. And I barely made it fit, but we're going to make it fit. All right. Now let's talk about our equations. Going back, I'm kind of working backwards a little bit. Going back to what we first talked about, that y equals a times b to the x. If you don't remember it, go back and look at it real quick. But the examples that we have here says we're going to use 2 points. Should be 2 points, not point, to write an equation. So basically what we're given here, we're going to use that to write an equation, just in the form y equals a times b to the x. This is pretty much, honestly, what an SAT question will look like. So it's pretty simple. So this first one's actually pretty simple because there's 2 things that you need. I'll change that color. So that's going to be y equals a times b to the x. Remember, this is your rate or your common multiple, and this is your y-intercept or your initial value. So I already know the y-intercept in this problem is 1 because I can see it. Okay. Now the other thing you want to look at, notice this is differing by 1 each time, so it's going in order. Even though it's starting with a negative, it's still going in order. So I want to see, what am I multiplying by every time? What is that? My number is going down. So I'm multiplying by a fraction, and it's getting cut in half. So I'm multiplying by 1/2 every time. So I know my rate now is 1/2, so that's going to be b. So I have my equation. It's y equals, I don't even need the 1. It's just b to the 1/2. Or why am I saying b to the 1/2? B is 1/2. It's 1/2 to the x. If you wanted to go 1 times 1/2 to the x, that's fine. Just know that's not what your answer would look like on the SAT. Just the 1 wouldn't be there. And hopefully you'd still be able to figure that out. So I don't think it would really hurt you, but you know, you're not going to see that on the SAT. Okay. And then next up, this one, you can kind of see the y-intercept as well. You know, that's 1, so that's 2. So it looks like it's going right through 3. So I know on this one that a equals 3. This one, at the same time, though, you're trying to find what b is. So here I know I have a point 0, 3, and this second point looks like, you know, that's 1, 2. So I'm going to use those points to figure out what am I multiplying by. So I'll go 0, 1, and then 3, and 2. Now I got to figure out what am I multiplying by. How the heck did I get from 3 to 2? So you're not sure how to get that. Here's how you kind of work it out. Here's what you're asking yourself. 3 times what number will give me 2? That's what you're trying to figure out. What am I multiplying by? 3 times something would be 2. It's a common multiple every time. So here you would just have to divide by 3. And there's your rate. That's 2/3. So that's B. So B is 2/3. Should be a fraction because your graph is going down. So you have y equals 3 times 2/3 to the x. Maybe you can have in parentheses if you wanted. Again, it won't matter which terms you use, and you have different numbers, but I could have picked, and again, it's hard to tell. That's the only good point I would use. This is like maybe in between 2 points. I don't want to use that. These other points, you can see how it's kind of hard to tell where they're at. Maybe this one looks like it looks like it's at 1, but if you look really close, that point looks like it's a little under 1, so I wouldn't want to use that. So these are probably the only 2 points you can use on this one, is 0, 3, and 1, 2. So I would show you another example how it doesn't matter which points you pick, you're going to get the same rate, but those are probably the only 2 points you can use on that problem. So I can't really show you that. But the rate doesn't change. It doesn't matter which numbers you pick. The rate will always be the same. Just pick, it's easiest if you pick 2 numbers right next to each other and test it from there. But it's all about finding the y-intercept, finding the rate. You do that, you'll be all right. And then the last ones, we'll wrap up here. This is, again, the other version you'll see on the SAT, and even see it, like example and SAT example down below. There's your word problem. There's your points. So it's kind of, you'll see how these apply to the SAT. This one says, write an exponential growth or decay function to model each situation and find the value of the function after the given amount. So based on the information they give us, we need to plug those values in to the appropriate points for A and B, and we're just going to evaluate it. So in this case, we have annual sales. So it's annual sales for a company are 149,000 and are increasing at a rate. Remember that keyword's at rate and that percent, right? At a rate of 6% per year. So going up 6%. So here's what we're going to have to do on this. A, which is our initial value, we're starting at 149,000. Now B, we're going up. We need to make sure that our number, our rate, has to be greater than 1, or else it's not going to increase. So just like when we decrease by a percent, we subtract from 1. If we're increasing by a percent, you're going to need to add that percent to 1. So our rate in this case is going to be 1.06. And that's important, or else you'll realize your answer is not going to be close to what they want. So my equation, in this case, would be y equals 149,000 times 1.06 to the x, where x is your number of years. So that's, first off, that's your equation. Second, they want to evaluate this after 7 years. So what you would be doing at this point, you're going to take this equation, try to just copy the equation. So I'm going to take that equation, and we're just going to take this value right here, the x, and call it 7. So I do have a calculator. Of course, it's dead. So Mark, if you want to do that one for me, my calculator's dead. 1.06 to the 7th power. Get that. and multiply it by 149,000. Like I have my calculator just dead. I have another one, but I'll let you do it. Okay, I found that one's dead. I got another one that'll work. I don't like it. It's just a nasty guy. Okay, that's fine. I'll do 1.06 to the 7th is 1.5 times 149,000. I get, in this case, it's going to give me 224,040. So 224,040 thousand. It's point 0.9, but they usually will tell you to round to the nearest, and I guess that'd be nearest dollar. I'll just put a 1 in there. This is 0.9, so I'll just kind of throw it in there. So yeah, it's really, I'd say the thing I try to get you on is that rate. You don't have to add 1. You type in 0.06. Not really going to work out for you too well. Your answer would be way off, and I don't even have that as an answer choice, so I want to be careful on that. And the last one we'll do, we got a book. Value of the book is currently initial value $58. Now it's going to decrease. We're decreasing at a rate of 10% per year. So in this case, A is $58. That's your initial value. But B is going to be 1 minus 0.10. Again, you're decreasing. You got to subtract that from 100%. So that means you're going to be left with 90%. I'm putting 0.90 just so you know it's 90%. You can just write 0.9 if you wanted. B is going to be 0.9. It's going to be every year you're going to have 90% of what you had the year before. So your equation in this case is going to be y equals 58 times 0.9 x, which is 0.90x. It doesn't matter. So that's your equation. A lot of dots right there in the middle. You hopefully get what I'm doing there. Now this one they're saying 8 years, so we'll just go y equals 58 times 0.9 to the 8th power. Again, I got my little calculator working here. So you just multiply that one out as well. 0.9 to the 8th times that by 58. And this one, so it says, I'll round this one off to the nearest cent. So this will be 24, in 8 years it's going to go down to $24.97. Again, your answer should somewhat make sense. I mean, you start at $58, you're going down 10% a year, 8 years. I mean, it makes sense. You'll probably be around that point after 8 years has passed. So, again, a lot of this stuff, like you're dealing with like exponentials, or maybe I know you're saying you're using synthetic division, which is great. Maybe remainder theorem. These are all simple concepts. They're just from Algebra 2 that people tend to get a little scared by some of these concepts. And some of them, when they're taught in Algebra 2 classes, and maybe in pre-calc classes, they're taught at a way higher level than the SAT will even test you. So all I'm focusing on is what you need for the SAT. This is all you really need to know, and nothing more when it comes to these concepts. So again, the goal is obviously to just master just these basic concepts, because these are going to be all mediums and hards, which is nice, because those are the ones you're not supposed to get right. And if you're able to do them with relative ease, and that is increasing your score, and that's what we're really trying to do here. So I'm going to go ahead and give the assignment for this week, and I'll write it down. And I'll put in an email too, but I just want to remind you of it. It's going to be page 101. I'm going to take you up through exponentials. So there we go. So page 101 to 104. I'm going to write it down here. I will put the date on this one, so it's 7/12/16. So page 101 to 104, and it's numbers, that was 14, I believe, through 45. Again, page 101 to 104, 14 through 45, and I'll even write it here, so I'll write at the beginning here so I don't forget that either. Page 101, 104, number 14 through 45. And again, the next week, what we'll do is really just go over the last couple lessons. It won't take that long. We're almost done at this point, and then we'll just kind of be doing a review of the course, talk about what's on the exam that we'll be doing the final week, and that will really wrap things up. So if you have any questions between now and then, let me know. If you see the video, again, let me know if you have any questions. We'll try to answer those, and if not, I'll take some of those questions next week. All right. Hey, I can't believe it didn't shut down on me. I got kind of scared there for a second. So I know now, Mark. I gotta let that thing reset on its own. I figured it out. I hope. All right. You have a good night. I'll see you on Thursday.